So in the figure to the left, x, y, and z are all squares, and the area of this triangle in here, which I'll just put in here, is 18. Remember that the area of a triangle is equal to 1/2 the base times the height. What's the length of one of the sides of square y? So we're looking for one of these sides. If we can get two of the sides of the triangle in the middle, we can figure out the hypotenuse using the Pythagorean theorem. And since we have the area already, one or the other of the base and the height. So now we already know that 18 equals 1/2 the base times the height. If we get either the base or the height, we can solve for the other one, and from there can figure out, we'd have a squared plus b squared equaled c squared, and we'd have that side length of y. Let's take a look at the statements. Statement 1 tells us that the area of square z is equal to 81/4. So let's just call little z the length of one of the sides. Little z squared is what equals the area, 81/4. So z is going to equal 9/2. We now know that z is our base of the triangle. So statement 1 gives us b. We would plug 9/2 in place of b up here. We could solve for h, and from there, with the base and the height, figure out the third side, the hypotenuse of the triangle, and that would be y. So statement 1 is sufficient. It's not 2 on its own, nor is it one of the insufficient statements. Statement 2 tells us that the area of square x is equal to 64. We'll say that the side length of big X square is just a little x. So that area is that little x times itself. That's how you get the area of a square. So x squared equals 64. The one side of square x equals 8. And here we've gotten the height of the triangle. So this one gives us h. And we could use the area formula that we have to solve for the base. And again, we'd have the two numbers that we need for the right triangle to figure out the third one using the Pythagorean theorem. Either statement on its own is sufficient for us to get what we want.